Comptia Network Plus course, Keypad Cipher locks. Cipher locks that use a keypad require a user to know the key code. These devices can also come with additional security features. The lock can be combined with a set time for opening the door as well as a battery standby systems. The three types of alarm systems are available. A burglar alarm interface is available to indicate when the door is breached. An error alarm can reveal someone tries to guess the code. Finally, a hostage alarm can be triggered to indicate that an entry was made under duress. Security guard. In cases where judgment may be required to control entry, a security guard may be advisable. While the cost is generally higher than with an automated systems, there are advantages to this. This offers the most flexible in reacting to whatever occurs. One of the keys to success when using guards is to ensure that they are trained with a response to every conceivable eventuality. Finally, the biggest advantage is that guards can use discriminating judgment in a situation which an automated system cannot. Logical security configurations. Now that you have your physical network locked down, right, it's time to review the security configuration of your network. The same concepts that apply to physical security apply here. First, you want to ensure that your network has an outside barrier or a perimeter defense. This is usually achieved by having a solid firewall. It's best to have an IDS or IPS of some sort as well. Figure 1518 shows what this might look like. This may be enough for your company, but may not. Let's say that your network serves several distinct departments at your company. The admin, production and sales group all have their own unique needs. What you can do now is divide up your internal network into smaller administrative zones by creating VLANs and using a DMZ. Maybe your network would logically look like one that is shown in figure 15.9. Finally, your network might be similar to the one shown in figure 15.9 but just larger. Maybe traffic is heavy and you need to break up physical segments. Perhaps different groups are in different buildings or on different floors of a building that you may want to effectively segment them. This could be any number of reasons for you to physically separate your network into different groups, effectively partitioning your network by using multiple routers as shown in figure 1520. Risk-related concepts. All organizations should identify and analyze the risks they face. This is called risk management. In the following sections, you'll find a survey of topics that all relate in some way to identifying risks and mitigating them. Power management. Power is the lifeblood of the enterprise and continued access is essential. In this section, we'll look at a few mitigations or countermeasures. Redundant circuits. Data centers usually deploy redundant power sources to maintain constant power. Redundancy can be provided in several ways. Parallel redundancy or N+1 option describes an architecture where there is always a single extra UPS available. That's the +1, and the N simply indicates the total number of UPSs required for the data center. As the system runs in two feeds and there is only one redundant UPS, this system can still suffer failures. N2 redundancy means the data center provides double the power required by the data center. This ensures that the system is fully redundant. Dual power supplies. Redundancy also refers to using redundant power supplies on the devices. Many servers come with two supplies and you can buy additional power supplies as well. Always ensure that the power supply you buy can supply all the needs of the server. Disaster recovery. A disaster is an emergency that goes beyond the normal response of resources. The causes of disasters are categorized into three main areas according to the origin. Technological disasters, device failure. Man-made disasters, arson, terrorism, sabotage. Natural disasters, hurricanes, floods, earthquakes. The severity of financial and reputational damage to an organisation is largely determined by the amount of time it takes the organisation to recover from the disaster. A properly designed disaster recovery plan (DRP) minimises the effect of a disaster. The DRP is implemented when the emergency occurs and includes the steps to restore functions and systems so the organisation can resume normal operations. The goal of the DRP is to minimise or prevent property damage and prevent loss of life. Business continuity. One of the parts of the DRP is a plan to keep the business operational while the organisation recovers from the disaster, known as a Business Continuity Plan (BCP). Continuity planning deals with identifying the impact of any disaster and ensuring that a viable recovery plan for each function and system is implemented. By prioritising each process and its supporting technologies, the company can ensure that mission-critical systems are recovered first, and the systems that are considered luxuries can be recovered as time allows. One document that should be created to drive this prioritization is the business impact analysis. In this document, the impact each system has on the ability of the organization to stay operational is determined. The results list the critical and necessary business functions, their resource dependency, and their level of criticality to the overall organization. Our recovery sites. Although a secondary site that is identical in every way to the main site with data kept synchronized up to the minute will be ideal, the cost cannot be justified for most organizations. Cost of benefit analysis must be applied to every business issue, even disaster recovery. Thankfully, not all secondary sites are created equally. They can vary in functionality and cost. We're going to explore three types of sites. Cold sites. A cold site is a leased facility that contains only electrical and communication wiring, air conditioning, plumbing, raised floors. No communication equipment, networking hardware or computers are installed at a cold site until it is necessary to bring the site into full operation. For this reason, a cold site takes much longer to restore than a hot or warm site. A cold site provides the slowest recovery, but it is the least expensive to maintain. It is also the most difficult to test. Warm sites. A warm site is somewhere between the restoration and cost of a hot site and a cold site. It is the most widely implemented alternate lease location, although it is easier to test a warm site than a cold site. A warm site requires much more effort for testing than a hot site. A warm site is a leased facility that contains electrical and communications wiring, full utilities and networking equipment. In most cases, the only thing that needs to be restored is the software and the data. A warm site takes longer to restore than a hot site, but less than a cold site. Hot sites. A hot site is a leased facility that contains all the resources needed for full operation. The environment includes computers, raised floors, full utilities, electrical and communications wiring, networking equipment, and uninterruptible power supplies, UPSs. The only resource that must be restored at a hot site is the organization's data, usually only partially. It should take only a few minutes to bring a hot site to full operation. Although Hotsite provides the quickest recovery, it is the most expensive to maintain. In addition, it can be administratively hard to manage if the organization requires proprietary hardware or software. A Hotsite requires the same security controls as a primary facility and full redundancy, including hardware, software and communications wiring. Snapshots. Using special backup utilities, you can also perform what are called snapshot backups. There are a list of pointers or references to the data and are somewhat like a detailed table of contents about the data at a specific point in time. They can speed the data recovery process when it is needed. There are two types of snapshots: copy on write and split mirror. Keep in mind that snapshots are not a replacement for regular backups. In many cases, the snapshot is restored on the same volume as the data, so if the drive goes bad, you will also lose the snapshot. Copy on write. This type of snapshot is taken every time a user enters data or changes data. It only includes the changed data. It allows for rapid recovery from loss of data, but it requires you to have access to all previous snapshots during recovery. As changes are made, multiple copies of snapshots will be created. Some will contain changes not present in others. There will also some data that remains unchanged in all of them. Split mirror. This type of snapshot is created every time a change is made, but it is a snapshot of everything rather than just changes. However, as you can imagine, it takes a significant storage space and the restore process will be slower. SLA requirements. SLAs are agreements about the ability of the support system to respond to problems within a certain time frame while providing an agreed level of service. These agreements can be internal between departments or external with a service provider. Agreeing on the quickness with which various problems are addressed introduces some predictability to the response to problems. This ultimately supports the maintenance of access and access to resources. MTTR. One of the metrics that's used in planning both SLAs and IT operations in general is mean time to repair, MTTR. This value describes the average length of time it takes a vendor to repair a device or component. By building these into SLAs, IT can ensure that the time taken to repair a component or device will not be a factor that causes them to violate the SLA requirements. Sometimes MTTR is considered to be from the point at which the failure is first discovered until the point at which the equipment returns to operation. In other cases, it is a measure of the elapsed time between the point where repairs actually begin until the point at which the equipment returns to operation. It is important that there is a clear understanding by all parties with regard to when the clock starts and ends when calculating MTTR. MTBF. Another valuable metric typically provided is the mean time to repair, MTTR, which describes the average amount of time it will take to get the device fixed and back online. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.